Hey everyone, in this one I'm going to be discussing variations, which is included in both IGCSE and GCSE O-level mathematics of the Cambridge International Examination syllabus. And this is a topic which usually appears in paper 1. So when you're going for your paper 1 exam, make sure you practice this. And this is a fairly easy topic. It also can appear in paper 2 as a part in a longer question, since this is a smaller topic. And the following is the objective as stated in the syllabus. This states express direct proportion and inverse proportion in algebraic terms and use this form of expression to find out unknown quantities. They've further given a detail here that it may include linear, square, square root, and cubic variation for direct and inverse proportion. For example, they've given a question here. Y is inversely proportional, so they've got an inverse here, to the square of x. As they stated here, it could imply a squared variable. Given that y equals 2 when x equals 6, find the value of y when x equals 2. Now, there are multiple ways to solve this, but I'm going to go through the most common ways to do this. And we're going to look at all of these situations here. So without further ado, let's get started. I'm going to consider direct proportion. Well, direct proportion is a relationship of two variables, two things that we're considering, that when a change occurs to the first variable, say x, the same change is going to occur to the second variable, y. So if I say that x is directly proportional to y, we use this symbol here for proportion, there will be a similar change in y as well. So if there is an increase in x, there's going to be an increase in y. It can be in a different amount, but there is going to be an increase. So there should be a very similar change. It's not that if x increases, y should decrease. That would be something different. That would be a case of inverse proportion, but here we're considering direct proportion. And this is the same for vice versa. So I'm just going to write here vice versa, which essentially means that if there is a decrease in x, there would be a decrease in y. If we sort of flipped it the other way around, if they're telling us that there is an increase in y, instead of telling us that there's an increase in x, it automatically should project the image that x is also increasing. Let's put this a little bit more visually. That the number of trees planted, represented by the variable x, is directly proportional to the variable y, which is the amount of oxygen, essentially in whatever unit you're measuring, is directly proportional. So it's going to mean that the more trees that are planted in this particular area, the more oxygen is going to be released. And assuming that all the other variables remain constant, there is no change in any other factor that may influence the amount of oxygen, we can also deduce that more y or more oxygen may mean that there are more trees planted. So they're interchangeable. An increase in x will result in an increase in y, and an increase in y will also result in an increase in x. You may also give many other examples. For example, there's a tank, it's being filled of water. The more taps there are going to be, or the more speed the taps are going to be switched on it, the more water is going to be available in the tank. That they could be directly proportional. Similarly, if the farmer uses more fertilizer, there's going to be a higher produce of apples. So here, the amount of fertilizer used may be X, and the amount of apple produce or harvest may be Y. So there are many relationships and many variables that could be an example of this. This is just one of them. Let's give an example. So say y is directly proportional to the square root of x. So this doesn't apply to the situation. It may, but they're saying that y is directly proportional to the square root of x. Given that y equals 12 when x equals 36, find the formula for y in terms of x. So we know that y is directly proportional to x. The square root of x. We can say that y is the square root of x multiplied by something. That essentially means that square root of x is a multiple of y. So even if it's not, k may be 1. So I'm going to place the value of y right here. Y is 12. They're given a situation. They're always going to give you one situation by which you can actually apply in the formula, and then you can, by which you can apply in the general form, and then you can deduce the formula. So they've given you a situation. They're saying that these two variables, we're just going to treat square root of x as a variable. These two variables are directly proportional right here. And this may mean that y equals k, another variable, multiplied by the square root of x. So k may be 2. That means that the square root of x is y equals double of the square root of x. So if y equals, let's say 4, then x may also be 4 since it's the double that we're talking about. Here they've given a situation that y equals 12, so I've put that here, and k, the variable, they'll help us find what multiple square root of x is to y, so that we can deduce the formula. So x is 36. I'm going to apply it right here. Then I'm going to go right here and write down it again. We know that the square root of 36 is 6k. We can shift the variable to the left side, as it's commonly done. And then we can divide both sides by 6. If I'll divide this side by 6, it's going to give me 1k, which is the same as k. And if I divide this side by 6, it's going to give me 2. So k equals 2. But this is not where your answer stops. You actually had to find the formula. You know that the square of y is equal to double of the square root of x. So you're actually going to write it as a formula. So we knew that any direct proportional formula is y equals k times the variable, the next variable. So I'm going to write that as it is, first of all. And then I'm going to equal it to, then I'm going to equal it to y equals 2 multiplied square root of x, which is deduced from finding the value of k, which is the third variable here. So k is necessarily just like helping us to actually find the relationship between these two variables. Here they just told the type or the nature of the relationship and a situation, but they had set us to find out the exact numerical representation of it, which is its formula. And this part was about, 2 marks. So if you do this working, the examiner would be pretty convinced that you have derived the formula correctly. So now let's move on to the second part of this question, which is 1 mark. The value of x when y equals 10. Now we know the formula, which is y equals 2 times the square root of x. And they're given us another situation where one of the variable is missing, it's unknown, and we have to find it, whereas the other one is given. Since k is also given and another variable is given, we can find the unknown here. So 10 in this situation, y equals 10, and we don't know the value of x, so x will remain as it is under the root, and k is right here as 2, as we found out in the previous part. So now we're just going to algebraically solve this. 10 divided by 2, divide both sides by 2, you get this. I'm just going to write the variable on the left side. It's going to give me this, and I'm going to square both sides. So it's going to cancel out my square root, and I'm going to be left with 5 squared, which is again 25. So this is our answer for the second part. You see, I have done all the working step by step, so you'd easily be able to get that 1 mark. Even for 1 mark question, you really need essential working, otherwise you're not going to be given a mark, even if your answer is correct. We're down to another past paper question. If you can solve this already, please pause the video and try it out for yourself, and then come back to me and check your answers. I'm going to do it with you guys. So they say you that y is directly proportional to the square of x. So we know that y is directly proportional to the square of x. That means that y is actually k times x squared. That means that x squared is a multiple of y. It could be 1 if, and you might say that it's not a multiple, but actually it is in any possible way. Even if this is 1, it's going to give x squared itself. So I'm just going to write it down. They've given us a situation. Given that y equals 50 and x equals 5, find the value of y when x equals 3. So y equals 50, x equals 5. First step is to deduce the formula so that we can actually find the value of y. 5 squared is 25. I'm going to divide both sides by 25, and that is going to give me 50 over 25, and then again 2. So k equals 2, and our formula is now going to be y equals 2x squared. This is our formula. And now they've given us another situation. So find the value of y when x equals 3. We can simply solve this algebraically. I'm just going to plug in the value, and here it is our answer, which is 18, if I've not done anything wrong. So if your answer is 18, you're good to go. This one as well. So the answer to this one is, it's done in the following steps. Okay, so what I did here was I derived the formula. So I put in the situation that they've given. I applied the general method that we use for direct proportion. It's going to be different for inverse, so don't try inverse with this methodology. And then what I did was that I applied the formula with the variable that was known to find the unknown. And that is 12.5. If that's your answer, you're correct. Practice a little bit more with these questions that I'm showing you. This one, then we have the second one. I'm going to write the answers in the description box. Same method, absolutely same method. See here, they've given us the relation, then they've given us a situation, then we have to find the formula, and with it we have to find the unknown with a known variable. For this one, if you haven't done graphs, you can skip out this part, but these two are pretty much the same types of questions, so you can apply those. So we've done the linear. Linear is pretty simple. Y is directly proportional to x, and then the given situation. Square, we've done it among the past paper questions. Square root, right here, also a past paper question. Cubic variation. A cubic variation can just be y is directly proportional to x cubed. So that would be the same method, that would imply the same method. What you would only do is replace this square root of x with x cubed, and that will lead to a very different answer, but it's essentially the same thing. So we've done this. We've done a similar question for direct proportion. But before you go, I just want to solve another method of direct proportion, which many other students use. However, this is the method that I would recommend you guys if you're doing this. So with a cubic direct proportion question, I'm just going to do this method number 2. So with this, they're just saying that y is directly proportional to x cubed, and given that y is 2000, so I'm just going to write 2000 right here, and when x equals 10, so I'm just going to do this. You can write a ratio symbol, that's more appropriate. Find x when y equals 27,000. So y is 27,000. And x is unknown, so we're just going to write x right here. And for direct proportion, we're just going to directly cross multiply, if that's what you want to call it. We multiply 2000 with x, and we multiply 27,000 with 10. And that will give us 270,000. And if we divide by 2000 on both sides, we'll get something like this. 135. Now, this is a little bit shorter. It does not give you the formula, but for the formula questions, you're going to solve it like this. And it's usually coming with a formula question. So I would recommend this way. However, this is much shorter if they just ask you a direct question just like this, probably of 2 marks. So if you do this working, you're also going to get the same marks. And another note that I want you guys to make is that if x and y are given in units, you're also going to give your answer in units, if not so already given for you, because that way the examiner knows what variable you're talking about. So that's it for this video. We have covered linear, x implying x, square, x squared, or y squared. It could be the other way around, as I indicated. Square root of x, and cubic variation. So x cubed. Not cubic root. So these are the 4 that usually come and most probably will come in your exam. So you should know how to deal with these 4 situations. And if there is any real life problem, they're just going to give you 2 variables. You're going to specify what these variables are, and then the method is the same. So please like the video and move on over to the inverse proportions video.